Hello friends, today we will go with the next problem based on work energy principle. Now when you see the problem says that a wagon weighing 490 kilonewton starts from rest, runs 30 meter down on inclined surface and strikes a post. If the rolling resistance of the track is 5 Newton per kilonewton, find velocity of wagon when it strikes the post. If the impact is to be cushioned by means of bumper spring having K equals to 14.7 kilonewton per mm, determine the maximum compression of the bumper spring. Now this is the figure which is already being given. Now we consider this situation as position 1. This distance is given as 30 meter and there is one term mentioned here is slope 1 in 100. Now what are the data being given? The first data which is 490 kilonewton, Ng equals to 490 kilonewton, which is 490 to 10 to the power 3 Newton. Now rolling resistance, when you see this rolling resistance, we can say it as mu. Why mu? Because F is equals to mu into N and mu is equals to F upon N. So F has a unit Newton upon N. N is a normal reaction having a unit kilonewton. So this can be mentioned in the terms of mu. So F in mu is equals to 5 into 10 to the power minus 3 Newton by Newton cancelled. Okay, after then there is a K which is K 14.7 kilonewton per mm. As you already know that the K is stiffness constant or spring stiffness or spring constant. So 14.7, if I am converting into Newton per meter, then it is 10 to the power 6 Newton per meter. This is the position 1 when the wagon was here. Now we'll see the position 2 when the wagon reaches to the bumper and it has maximum compressed the spring. So if it has maximum compressed the spring, so when you see the position 1 and then position 2, there is a difference of x, means the compression of the spring has happened x. That is position 1 and position 2. Now let's see how it will be solved. So the first we'll be seeing as the wagon is moving down, so we'll be taking work done by gravity. So work done by gravity says that mgh, as it is moving down, so g is negative, h is negative, so it is positive. So mg here it is 490 as we have seen already here. So 490 to the power 3 into 30 sine theta. Now why it is 30 sine theta? As you already know in a formulation that work done by gravity has an h. So what will be the h? H will be this distance. So h will be this distance. So if this is 30, this is theta, then this will become 30 sine theta. I hope you understood this. Now here the slope is given as 1 in 100, that means 1 by 100. So if you'll see here 490 to the power 3 into 30 sine theta. Now sine theta can be equivalently said as tan theta, which is equals to 1 upon 100. Now why we are doing this? If you'll calculate it, it will give you the equivalent value. Now here you are getting the value with this equation as 14,147,000 joule. The next is your rolling resistance as in mentioned in the question. So work done by rolling resistance will be your F rolling into S. As mu coming into picture, so F rolling will be minus. Why? Because work done by frictional force, if we'll take, it will be minus mu into N into S. Similarly here also it is mu, which is 5 into 10 to the power minus 3. If you'll see here 5 into 10 to the power minus 3, so 5 into 10 to the power minus 3, and as I told you mu into N into S, so N will be your 490 into 10 to the power 3. Now the question arises, how come only N will be 490 into 10 to the power 3? If we'll see in the question, we'll have a look that if here the N will act, if here the n will be acting, so you will be having a cos component of w, which is w cos theta, cos component of w. But when you'll relate this, you'll be getting cos theta as in 1, and that's why here it is mentioned only 490 into 10 to the power 3. Otherwise, if it is written 490 into 10 to the power 3 cos theta, the cos theta is 1 basically. If we'll calculate it, you will be getting the value 1. So 490 into 10 to the power 3 into s. The s distance is this distance, which is your 30 meter. When you solve this, you'll be getting minus 73500 joule. Now seeing a third part, work done by spring force as the spring is coming into picture. The formula is half k x1 square minus x2 square. Half k is your, when you have seen 14.7 into 10 to the power 6, so k is your 14.7 into 10 to the power 6. Now talking about an x1. So in the case of position 1, there was no deformation in the spring, so that's why x1 will be taken as 0. Similarly, at position 2, there is a deformation in the spring of x, so here x2 will be taken as x square. If we'll solve this whole term, you'll be getting minus 7.35 into 10 to the power 6 x square. So these are all the work done which will be applicable for this particular diagram. Now, when you'll have a look with the work energy principle, so what does work energy principle say? The work energy principle says that all the work done equivalent to change in kinetic energy. So change in kinetic energy at position 2 minus change in kinetic energy at position 1. So we have substituted 14,700 minus 73500 minus 7.35 into 10 to the power 6 x square equals to half m v2 square minus v1 square. Now when you'll take these two terms, then you'll be getting this answer again, 73500 minus this value equals to v2 and v1. When you m is having some value which is your 490 into 10 to the power 3 divided by 2. Now talking about v2 and v1. If this is the position, at this position what is v1? So if you'll see here, starts from rest, so v1 will be 0. Similarly, when you'll see further, determine the maximum compression of the bumper spring. So if it will reach to maximum compression, again it will become at rest, and that is why here v1 and v2 both are considered as equals to 0, and that's why it is mentioned here 0. The whole term will become 0. If you'll solve this term, you'll be getting x equals to 0.1 meter, which is equivalent to 100 mm, and that is your maximum compression. Till now, I hope you understood the solution. Now coming to the next part, as mentioned in the question, determine the maximum compression is done, which was 100 mm. Now we'll find out the velocity of the wagon when it strikes the post. Okay, so when you'll see a velocity of a wagon, so let's have a look with this part. For velocity of wagon when it strikes the post, at that case, work done by gravity, which is mgh, that is similar value what we have seen earlier. Work done by rolling resistance, again minus f into s, which was the previous value. Here work done by spring will not come. Now why? Because the velocity of a wagon is being asked when it just strikes the post. So the spring is not coming in the picture right now. So by work energy principle, work done is equals to change in kinetic energy. This value we have substituted it here, minus this value substituted it here, is equals to half mv2 square minus v1 square. If we'll solve this, you'll be getting this half m, at the place of m I'm writing 490 by 9.81. Why is it so 490 into 9.81? Because here 490 itself is in Newton, in kilonewton. So here it will be your 490 into 10 to the power 3. 490 into 10 to the power 3. V2 square minus 0, as mg was 490 into 10 to the power 3 Newton. So here m upon g, force upon g, or a weight upon g, will be giving you m value. Hence we are taking here v2 value as 1.715. Now v1 here is taken as 0. Why? Because it is starting from rest. With this, I hope you understood the whole question and the solution of the same, and hope you like the whole solution of the problem. Thank you so much.